Now, if you're wondering where do they get these van der Waals parameters, the A and B, they calculate it from the critical point. Okay, experimentally determined critical point of your substance. So T sub C here is the critical temperature. So that's the temperature at the critical point, and P sub C is the critical temperature. It's the pressure at the critical point. So how is the critical point determined? Let's look at a PV diagram again to illustrate how the critical point of a gas is determined. Okay, again, imagine you have a gas. Okay, right here at very high volume, you compress your gas. Okay, so you have a gas. Okay, you push on that gas to shrink it. What happens as you shrink it? Pressure goes up, right? Eventually, it reaches a pressure where if you keep shrinking it, the pressure doesn't change. What does it mean when the pressure is not changing? That means your molecule is going into a liquid or a solid. You start forming a liquid or a solid, and then what happens eventually, as you keep pushing it, as you keep shrinking it, eventually everything turns into a liquid or a solid, and then the pressure goes up really fast. Okay, for you to be able to shrink it even more, okay, you're gonna have to exert a drastically very high pressure, because once your molecules are in a solid or a liquid, they're as close as they can be. Okay, it's getting too crowded there. You get all these charged particles repelling each other. So what happens at a higher temperature? If you did this at a higher temperature, what you'll find is it's going to take a higher pressure before you can get the gas to liquefy or deposit as a solid. So we say that the vapor pressure, this is the vapor pressure at lower temperature. This is the vapor pressure here at a higher temperature. So the vapor pressure increases. Okay? But that's not going to continue. Eventually what happens is you get a curve that looks like this, where that flat area of your curve, flat region of your curve is going to get shorter and shorter and shorter. Eventually you get this point right here, which is called the inflection point. That's called your critical point. In math, they call that an inflection point. Okay? And at that point, okay, you'd say beyond that temperature, beyond this critical temperature, you can no longer liquefy or solidify a gas by just increasing its pressure. So you have beyond this, you have what's called a supercritical fluid. Okay, so this point right here is your critical point. The pressure at that point is the critical pressure. The temperature at that point is a critical temperature. The volume at that point is a critical volume. And so based on the values of the critical temperature and the critical pressure, you can calculate the van der Waals constant. Now, how did they determine that? You have to use a little calculus there. At that point, you say that the derivative of the pressure with respect to molar volume is equal to 0, and the second derivative is also equal to 0. But we're not going to go into that. Okay, that's for an upper level class. Suffice it to say, that's where the values come from. Okay.